Welcome back, everybody. Welcome there, Michael. I'll just do the brief introduction. I want to welcome Sunshine Hydro Executive Chairperson Michael Meyer to the stage. The Djandori Gung-i Project, formerly the Flavian Project, is a greenfield project of 600 megawatt hydro, 300 megawatt hydrogen, 220 megawatt green energy, and 11,000 megawatt hydro energy storage. Wow. Sunshine Hydro Executive Chairperson Michael Meyer is a serial entrepreneur with venture capital experience in startup ventures, venture capital, and sustainable development. He's also passionate and has an interest in bringing engineering and economic resources to projects to support our social and environmental challenges. Please welcome Michael Meyer.
Thank you, Nicola. Good morning to everyone. I will begin the presentation. Well, welcome to the conference, the Connecting Renewables. It's a pleasure to be here this morning. And I'm going to talk you through what we're doing in the Central Queensland region. So first I want to acknowledge I'm in Brisbane talking to you this morning. We're on Turrbal and Jagera land, and I want to acknowledge the traditional owners, past, present and emerging. Also, I'd like to acknowledge the Gurang and the Gurang people who are the traditional owners of the land where we are doing our project, Djandori. And it was the Gurang elder, Dr. Kerry Blackman, who gave the project its name. Djandori Gung-i means spirit in the water. And as a pumped hydro project, it was a name that speaks eloquently to what we're aiming to do in the Central Queensland region. So let me talk you through what we're doing. It's a privately developed pumped hydro project, and the site, there's a picture in front of you on the screen, is the site where the project is going to be constructed. It's just west of the Pacific Highway. It's about 60 kilometres from Gladstone. And I'll use my mouse to show you the upper reservoir sits up here on basically up on the highest point of the Great Dividing Range. The lower reservoir will be down in this region between these two knolls. And it is a 600 megawatt pumped hydro project. The project will have 11 gigawatt hours, 18 hours of storage at a minimum. The thing that attracted us to this site, apart from its proximity to Gladstone and of the transmission lines, is the head. The site has a 450 megawatt head, which was really, really attractive to us. We'd looked at hundreds of sites across Queensland and we finally settled on this one. The project at the scale we're doing it will be producing 300 megawatts of what is called 24/7 carbon-free energy. The definition of carbon-free energy came out of COP27 last year, where you're matching green energy hour by hour. And the project is achieving, we've been running the project as a digital twin for 4 years now, about 98% plus reliability of carbon-free energy. We also, because it's a super hybrid, we integrate the pumped hydro with 300 megawatts of electrolysis and liquefaction and or green methanol production. And by integrating that, we'll get, in addition to the 300 megawatts of carbon-free energy, we'll be producing 600 tons of liquid hydrogen or gaseous hydrogen, and that could translate into 600 tons of green methanol a day. And then we'll have a reserve fuel cell hydrogen turbine of 50 megawatts. This system, this super hybrid system, is then integrated with 1.8 gigawatts of wind, which will be developed by third parties, and it'll come from throughout Queensland, from far north to the Darling Downs. And the modelling that we've been doing over these last few years has been drawing actual data from wind farms. To give you an idea, that the funding through FID is about 55 million, and we're talking to long-term development partners about that. And the project itself ultimately is in the order of a $3.2 billion project, of which on the pumped hydro side, it's about $2 billion, and on the hydrogen and the methanol, it's about a $1.2 billion project. So that gives you an idea of the scale. So let me just go to the next slide. This just shows you where the reservoirs are. The road that connects is called Blackman Gap Road, which connects to Miriam Vale and then through to Gladstone. But that's the siting of the reservoirs. And it also, this shows you the siting of the reservoirs. It shows you the drop shafts, shows you the tail race tunnels. The analogy I could give you on this is that it's a similar size to the Kidston project in far north Queensland. The amount of tunnelling involved, other than the tail race, is very similar. So, and the Kidston project, the tunnelling is now complete, and the chamber for the power station is built, or it's actually dug out. If you replace that project to the Djandori to be a similar, but the difference is that we have double the head than they do. We have 450 metre head. They have about a 200 metre head. So we're getting twice the amount of power out of the project. So this is just some of the early conceptual engineering drawings, but we have done quite a lot of work on that. This locates the project in the Central Queensland region. You've got Gladstone at the top of the map, and you have the pumped hydro, the two little blue dams, reservoirs down the bottom of the page. And we have this, what we call a green hub, which is just south of Miriam Vale. We've secured the land, and this hub will be the host for the switch yard. We're hoping to have rail yards here. We're looking to do the hydrogen and the methanol production on this site, and then we're looking to do like an industrial estate for companies that want to co-locate and be getting carbon-free energy. So this is a 250 hectare site, 500 acre site. It's right on the rail line. It's very close to the highway. And then also we're doing, as a stepping stone to the full project, we're working with Central Queensland University to do a mini project close to the port. And we're working on that as a stepping stone. So the pumped hydro project itself is obviously we're years away. Pardon?
Yeah, to click here.
Yeah.
Now the arrows work.
Yeah. Okay. So this is where it's located in the region. This is the map of the green hub on Dales Road and all the components of this. We'll do some behind the meter solar. Most of the clean energy will come from wind across the state, but we will do some solar. So this is what we're looking to have here is the electrolysis, the liquefaction plant, the switchyard, solar, the industrial estate. And this is, it is a very good site for us. So this concept of the superhybrid, I'm just going to segue back. It's not just the pumped hydro project. We integrate it, as I said, with the wind and the solar, with the electrolysis and the methanol and the hydrogen production. And again, I repeat that we'll be producing the 24/7 carbon-free energy, and we're in discussions already with off-takers, different types of off-takers for that scale of carbon-free energy. We're also in discussions with potential off-takers for the green methanol and likewise for the green hydrogen. So, and all of this is made possible by the software which Sunshine Hydro has developed. Chris, the founder of the company, started building this software about 6 years ago. It's called ESOP, and it's the optimization tool. It's the tool that brings together these moving parts and optimizes the outcome of these different pieces of assets. This is the rough timeline. We're looking for get FID towards the end of approval towards the end of in 2024, FID in 25, and then sort of 5 years to build. Similar timeline to what Kidston is working on. So that gives you a bit of the timeline. This is the site in Gladstone within the university where we're looking to do the mini superhybrid, and we're in discussions with suppliers of the we're going to be using flow batteries, obviously, not pumped hydro at the university. So we're in discussions with suppliers for the electrolysers and the flow batteries to run it. So we'll be running a mini version of the whole super hybrid within Gladstone. We have an agreement with CQU about the research side of the project. I've just used the analogy of ESOP. It's a bit like the conductor of the orchestra. So if you think of the wind and the solar and the pumped hydro, they're all the different instruments. And ESOP is like the conductor. It makes all these different parts come together and are optimized. I'll show you. This is the project I can show you. You can see we have other projects that we're working on in New South Wales and in Victoria, but I can show you this project running in a simulation. So if I click on here, you'll actually see the project as if it was running today in real time. Trusting that you can see that. And it's not quite up to date. The time is what's showing now is 11:30. I know it's a bit later than that, but it should reset in the next. There we are, 12 o'clock. So you can see at the top of the screen, this is the current in the NEM. The price in the NEM is $8.28. And what we're doing is pulling real data from 240 megawatts of wind from wind farms across Queensland, 474 megawatts of solar. And you can see out to the left, we're always defending these long-term contracts of 300 megawatts of carbon-free energy. So we do that 24/7, 365 days a year. We're always supporting that amount. The balance of it, we're pumping into the upper reservoir. We've got 175 megawatts going into the electrolyser to produce gaseous hydrogen. We're running the liquefier and we're producing liquefied hydrogen. And what we can do is we can see the charts of what's happened over the last week. This is the behaviour of the reservoir. Looking back over the last week, and then I can look forward and see what the wind forecast is for the week. And then we're able to follow the project. Looking back over the last week, the coloured squiggly lines of the performance of the wind farms across Queensland. The flat green line is always producing that carbon-free energy, 300 megawatts. The upper line at 600 is when the electrolyser is going full time, and you can see over the last week it's been turned off a lot of the time because there hasn't been a high production of wind over this past week. We're able to then follow the performance in gross profit, in physical production. So we've been tracking this project as if it's been running for the past 4 years. And an interesting reflection, just coming back to this part of the slide, was when Chris first started modelling a 600 megawatt pumped hydro project 4 or 5 years ago, we were only producing about 50 megawatts of carbon-free energy. So in the space of since we've been designing and operating as we now have got it up to 300 megawatts of carbon-free energy, a significant improvement to optimize these assets. So it's quite unique. It's the first of its kind, not only in Australia, it's really the first super hybrid in the world. And we're in discussions with large investors to come in to help us develop this project through to FID and then subsequently to construct it. So I think at that point, if I want to quit out of this and go back to...
Go down to here, to PowerPoint.
Yeah. Yeah, so we have projects elsewhere in Australia. The one we're talking about obviously is the one in Queensland. So I'll hand back. I'm really interested to see if there are any questions at this point.
Thank you, Michael. That was really, really interesting. The data that you were looking at, is that available on the website for the delegate to actually view, or is that something that you manage internally, those schematics?
The schematics or the live simulation?
The live simulations.
It's something that we share with people. It's not publicly available because it's literally we're running this as a digital twin, and we're constantly improving the performance. We're literally in the process of seeing whether we could go from 300 megawatts of carbon-free energy to 350. So it's literally a living operational project, if you will. So we don't generally share that unless it's under an NDA with a a counterparty with whom we're in discussions.
Oh, it's just fascinating to watch. You
Yeah.
spoke early in the presentation about the railway yards. What's the value of the railway yards? Are you looking at using that to bring construction components in, or?
No, there's a number of things. So, for example, if we're producing liquefied hydrogen in that area, right? There's two ways we could get the liquefied hydrogen to the port. We could design and build a pipeline through to Gladstone, but we think the better way would be actually to have a marshalling yard where we can fill the trains and take it to the port. So one of our counterparties is looking to be exporting, large amounts of liquefied hydrogen to Northeast Asia. So, and then also if we're doing methanol and we're talking to a counterparty who would be looking to produce green methanol for their shipping fleet. So we could be bringing in biomass by train, producing the methanol there, and then again shipping the methanol out to Gladstone. Likewise, we're talking to potential industrial manufacturers who want to be behind the meter, and they would be able to train out their finished products to the Gladstone port or into Brisbane. So it would serve multiple purposes. It's the idea of being able to get access, and we also have access to the highway, of course. So it's the idea of a green hub. It's the idea of this, that we're producing carbon-free energy 24/7. We're producing green hydrogen, green methanol, and it's what is the best way to distribute any finished products or any gaseous or liquefied hydrogen, from that site.
The railway network and the port network at Gladstone is quite significant already. Are you aware of any upgrades on the port side of things to meet the capabilities for export?
Look, I'm not specifically. We're with the university, we're in discussions with the port. I mean, the port, I'm aware, Gladstone is becoming a centre of green hydrogen. There are other proponents, as I'm sure people who are in attendance are aware. So I think Gladstone has an ambition to become an export focus for green fuels, and whether those green fuels are gaseous hydrogen or liquefied hydrogen or green methanol, I think it will become a significant part of its own business operations. If you look forward a decade, it will become a significant part of its operations.
Being a Central Queensland girl myself, back in the day, it's Gladstone and Greater Central Queensland has always been a melting pot for a range of industries. It's so lovely to see the renewable sector setting up home there in Central Queensland.
Yeah, it's Gladstone I think of it as a bit like I've been doing business up there for over 25, 30 years. I did the Sunrise at 1770 development 25 years ago. So I've been in the area. It is like the Ruhr of Australia. It is an industrial hub. It's gone through reinvented itself many times. And I think that the vision of a green Gladstone in the next decade is one that's very realisable. And the jobs, the the development of future-facing industries. Like we're talking to someone who's going to be producing very high purity aluminium in the area. And for them to be able to export that aluminium, they will have to be producing it with 24/7 carbon-free energy. You know, it won't be good enough getting the power from the grid because they won't be able to get the certification that's required. So all of those rules are coming into place. For example, the European Union, by 2028, in order to say that your hydrogen's green or your, be it liquefied or gaseous or methanol, you'll have to be able to show that you're producing it with hour by hour matched carbon-free energy, you know. So it's all those forces are coming into play for Australia, and for Australia nestled in the global economy, you know.
It's incredible, and it's nice to see some projects and construction activities happening a little bit further south in the Miriam Vale area as well. Miriam Vale as a township has very limited accommodation options. How do you plan to actually home the staff and manage this construction period? They can't all stay at 1770 Lagoons.
Oh, I'd love to. Yeah, very good question, Nicola. We're in negotiation with other pieces of land in Miriam Vale, and a part of the project will be to build a sustainable village. So we have a mind to be building probably 150, and they won't be dongas. These will be architectural design, sustainable homes for the workforce during construction. So during construction, we imagine there'll be 500 to 1,000 people. And obviously driving in from Gladstone or from the region is less than satisfactory. And then we would see those being converted to permanent housing or homes post, you know, once the project's in operation. So yeah, it's a very important part of what we're doing. We can't disclose where it is because we are literally in negotiations. But that has to be, for any of these projects of this scale, how do you provide sustainable, quality housing for the workforce is a very important factor.
Oh, 100%. And what happens to that said housing after those activities are completed is sometimes not always thought. It sounds like you're well in planning phases now, so it's a watch this space.
Yeah, indeed. Yeah, we're literally in the negotiation and see it as a very significant part of what we're doing.
It's very exciting for the greater Miriam Vale community, I'm sure. So, Michael, you and your team will be heading to the booth now.
Okay, well, thank you, Nicola. Thank you for hosting us, and thank you to all the audience for coming along today.
I very much enjoyed your presentation. Thank you, Michael. If any